2.4, we ended 2.3 talking about the last example where there was only one real and then there was two imaginary, and that's kind of what 2.4 is going to be talking about. So some of our quadratics have no real solutions, and so what we come up with are imaginary roots, and we use the small lowercase I. It comes from the square root of a negative, and if we have I squared, we actually get -1. This should all be reviewed because you definitely talked about this in Algebra 3-4a. When we talk about our imaginary numbers, they come from the complex numbers, and we put it as the real part and then the imaginary part, and that combination is called the standard form of a complex number. We always put the real part and then the imaginary part. So for example, here, even though the real part's written after it, we would rewrite it in front. The rest of these you can fill in vocabulary words from your textbook. When we add and subtract complex numbers, it's the same as if it was a letter. It really makes absolutely zero difference that it's an I instead of an X. The only thing that matters is that generally with an X, we would always put the variable first, but if we have an I, we're going to put the number part first. But how you combine them and add them and subtract them is all exactly the same. We put the real part with the real part, so 3 and 4 is 7, and we put the imaginary and the imaginary, so plus 5i. The real part goes first, and the imaginary goes second, but if there's none there, we don't put it. One thing you do need to be careful, and this always happens every single time, anytime we subtract, we have to make sure that we switch our signs because we forget to do that with our negatives. So that's really 3 plus 2 minus 3i, and the addition, just like we did in steps 1 and 2, doesn't change any signs, so it doesn't matter. And now we put our real parts together, which in this case cancel out, and we put our imaginaries, -2i. Just like we don't put 0i in the back, we don't put 0 in front for a real. On number 4, the plus we don't matter, but the negative we distribute, so -7, -i. We put the real parts together, and then we put the imaginaries, and in this case, they go away. Alright, now multiplication is a little bit different, and it goes back to this very first rule on the first page that said if we get an I squared, it becomes a -1. Because when we multiply, there is the potential for an I squared. Example on the first one. I times I, so we get -5i squared. But we have a value for I squared. The value for I squared is -1. Therefore, the solution is actually +5. The square root of -9. Well, the square root of a negative is I. Square root of 9 is 3. And we're multiplying that to the square root of -16, so 4i, which is 12i squared. And again, we have a value for I squared, so that becomes -12. When I distribute exactly the same. 3 and 4 is 12, 15i minus 4i minus 5i squared. Combine like terms, so the 12 stays. Then I get 11i. Well, this I squared is really a -1, so that makes +5. combine your numbers again. So 17 plus 11i. Distribute. 4 and 4 is 16. Minus 8i plus 8i minus 4i squared. 2i, 2i, it's 4i squared. Alright, we know I squared is actually negative 1. So I'm going negative 8i goes away. This negative 4, negative 1 really makes positive 4. So 16 and 4 is 20. Square just means we have two of the same thing. So distribute, we get 36 plus 12i plus 12i plus 4i squared. We get to combine those. We know I squared is really negative 1, which means this really is negative 4. So we're going to get 36 minus 4, and then 12i for 24i. So the adding, subtracting, multiplying really isn't different from what we do. The only kind of thing we need to be careful of is when we multiply and get that I squared, that we substitute it out for the negative 1. Now when we divide with complex numbers are very similar to radicals, meaning you can't have radicals in the denominator, you can't have imaginaries in the denominator. And the way we get rid of those is we use what's called the conjugate. It's the exact same word that we call it for radicals. And what that is that it's the same numbers, it's the same order, just opposite middle signs. We don't care about the front sign. So if they're positive, it stays positive. If it was negative, it would stay negative. The only thing that is different is an opposite middle sign. Everything else is the same. So on the first example, 2 over 3 plus I, the conjugate that I'm going to multiply top and bottom by is 3 minus I. Same numbers, same order, opposite middle sign. Now we multiply just like we would anything else. 2 and 3 is 6. 2 and I is negative 2i. 3 and 3 is 9. Now the whole purpose of a conjugate is that these middle terms, minus 3i plus 3i, cancel. They have to cancel. That's the whole purpose of a conjugate, is for those middle FOIL, if you want, the O and the I, those middle terms to cancel each other out. So since they will always cancel each other out, you do not have to actually show minus 3i plus 3i. What you need to go to next is now the last term, because we did the first, 3 and 3. We don't have to worry about our outers and our inners, and now we have last, negative I. Negative I is positive I squared. Well, we know I squared is negative 1, so we're going to get 6 minus 2i over 8. We do need to look, this does reduce, and it has to reduce everywhere or nowhere. Everything is reducible by a 2. And actually what we're going to do is we're going to put everything into standard form. So we are going to separate these out anyways, so that will help with the reducing. So I would put the real part and then the imaginary part. So this is much easier to see that this reduces to 3. Oops, I think I multiplied wrong up here. Plus I minus I is minus. Sorry. So when I do a minus 1, I get plus 1. So that becomes 10. So divide by 10. So 6 over 10 reduces to 3/5, and 210 reduces to 1/5. And we do like to have it in the form of A minus BI, so that the number is actually separated from the I, and the I is not in the denominator. If you put 1/5 I, it would be marked wrong, because we can never have I in the denominator. So when you're writing as a fraction, make sure you're very, very clear that it is not in the denominator. it is across from the fraction bar. Alright, try example 2 and 3 on your own. Take a minute, pause the video, try them, and then come back and I'm going to work through them. Alright, the conjugate for 3 minus 2i is 3 plus 2i. When I distribute on top, I'm going to get 12, 8i, 9i, plus 6i squared. On the bottom, I only care about my first and my last, so I'm going to get 9 minus 4i squared. All my I squareds become negative 1, so that this combines to a positive 4, and this combines to a negative 6. So when I simplify the 12 and negative 6, I get 6 plus 17i. 9 and 4 is 13. And we do want to write it in the a plus bi format. And we don't care that it's an improper fraction. We prefer that. Absolutely no decimals, absolutely no mixed numbers. So leave the improper fractions alone. Number 3, the conjugate, 2 minus 5i. When we distribute, we're going to get 16 minus 40i minus 6i plus 15i squared all over 4 minus 25i squared. The I squared is a negative 1, so it's going to change that to a negative 15. And the I squared negative 1 is going to change that to a positive 25. So when I combine like terms, I get 16 minus 15 for 1. 40 and 46 is negative 46i. And then 4 and 25 is 29. And we want to write it in proper form. The real part and the imaginary. And there's your final answer. Alright, looking at complex numbers when we're graphing is extremely simple because it matches up to exactly what we've been doing. The real part represents the x coordinate, and the imaginary part represents the y. So what we do is we just rename our axes. We call it the x-axis or the real axis, and then we call it the imaginary axis, which is our I values. So on number 1 here, I'm going to go x is 2, and then positive 4. So that's number 1. Minus 2 plus 3. So minus 2 on the x, positive 3 on the y. For this part, there's no imaginary, so it's just 3 on the x. Here there's no real, so it's negative 4 on the imaginary axis. And that's, seriously, it's just as simple as that. Now, I do want you to look at, let me give you these points here. If I call this A, could you tell me what is the point of that? Well, the real part is 2, and the imaginary part is negative 2. So over here, if I made this B, could you give me the point? The real part is negative 2, and the imaginary part is 1, so just 1 I. So be able to go back and forth between them. Alright, this stuff down here, we don't do too much about it, but it does talk about being bounded and unbounded. But we really don't do too much with it. But it does say that if I have -2 up here, this would have been 4 minus 2, -2, then this becomes 4 minus 2 for +2. Well, this is c squared, so 4 minus 2 for 2 is 4, plus the 2 of -2, so altogether we get 2. And then it's going to keep going, and we keep getting 2 and 2 and 2. So it's just a unique sequence that they like to look at, something unique in math. But we don't spend too much time with that. So here we have the conclusion of 2.4.